Okay, let's solve the number of pool balls problem. So pool balls are arranged in rows, right? So if I were to go here and do pool balls and maybe get some images of it, you see they're arranged in rows. So if I have one row, I have one ball. If I have two rows, one row, two rows, I have 1 plus 2 is 3. If I have 3 rows, I have 1 plus 2 plus 3 balls is 6. If I have 4 rows, that's 1 plus 2 plus 3 plus 4 is 10. If I have 5 rows, that's 15. So we say the number of pool balls given a certain number of rows. And what we realize is that it's just the sum from 1 to that number of rows. The sum 1 plus 2 plus 3. If we happen to have 10 rows, that would be 1 plus 2 plus 3 all the way out to plus 10. And so given a number of rows, like 3 rows, we want to return the number of pool balls in that many rows. These are also, by the way, known as triangular numbers. Okay, I'm going to copy this. I'm going to go here. No, I'm going to go here and paste this, and now we're going to solve it. So when I run this, initially, of course, it doesn't work. As usual, you know that when I run this, I will just get 42 because that's what we use as our placeholder when we haven't yet written a solution. So 42. Okay. So now the question is, how do I add the numbers from 1 to n, or 1 to rows in this case? Now, I could do it with a loop, only we don't know about loops yet, so forget that. So I want to do it with a formula. Fortunately, there actually is a formula, okay? So if you look here, instead of looking at pool balls, let's look at the sum from 1 to n, and here's the formula we have for this. And let me kind of move this over a little bit. You can see that the sum from 1 to n is n times n plus 1 over 2. It's right there, okay? And there's some pictures that try to tell us why. I'll revisit those later if you're interested. It's optional. But it's n times n plus 1 over 2. That's the sum from 1 to n, okay? So if I go back here, if that was n, the formula was n times n plus 1 over 2, okay? So it's not n. Here are variables called rows. So it would be rows instead of n times n plus 1, or rows plus 1, okay, over 2, okay? And that's the formula. Let's see if that works, okay? Go ahead and run that. And that's it. It actually worked. Actually, there's something that's a little weird, not horrible, but a little weird. Number of pool balls for 10 rows is actually 55.0, because that divide there, it's going to give us integer, non-integer division. It's going to give us floating point division. So when it does 55, it does 550 over 10, it gets 55.0. We know the answer is an integer, so we can do integer division, which looks like it works the same, only now we get a nice little 55. Either one's fine, frankly. Now, if you're curious, how does this formula work? Well, instead of going to n, let's first go to 100. If we add the numbers from 1 to 100, notice the first and the last one add up to 101. Second to last one, 2 plus 99, still 101. 3 plus 98, still 101. They're always 101 because every time I move one larger here, I'm moving one smaller there. So the pairs remain 101. How many pairs do we have? Well, we have 100 numbers, and we're making pairs, so half that many. So 50 pairs up to 101. So therefore, the answer is 50 times 101. If we look at it one more time over here, going up to n, now, whoops, I don't want to do that. Now the sums go, 1 plus n is n plus 1. All the sums are n plus 1. If I have n numbers, how many total pairs do I have? N over 2 of them. So we have, the answer therefore is n over 2 pairs that each sum up to n plus 1. So the total is n over 2 times n plus 1. That's where that comes from. You don't need to know that formula for this course. It's just interesting where it comes from. But you certainly do need to know, given that formula, how to turn it into Python code. Hope this helps.